In this tutorial, you will learn how to create windrows plots using the openair and worldmet packages in R. Windrows plots are valuable tools for visualizing wind patterns over a specific period. We will demonstrate how to generate windrows plots for different time periods, including yearly, monthly, and seasonal aggregations, using historical weather data from NOAA. Let us start with creating a windrows plot for the period 2014 to 2023. We will import NOAA data for the specific station and year, aggregate the data for all years, and then create the windrows plot. Firstly, we will import libraries openair and worldmet. Then define the start and end years for the period. Then initialize an empty list to store data for all years. Our station code is 40 61 10. We will loop through the years 2014 to 2023. Then create a windrows for the aggregated data. Print the windrows. Then finally save the windrows plot as a PNG file. The windrows shows that the average wind speed during this period was 2.5 meters per second. Southwesterly wind was the most dominant, contributing around 38% of all wind directions, and the strongest winds ranging from 6 to 50 meters per second primarily originated from the south and southwest. Next, you will create windrows plots for specific months. We will loop through each month, import NOAA data for specific station and year, filter the data for a specific month, and then create the windrows plot for that month. It may take a long time. For example, that's one of monthly windrows. Finally, we will create seasonal windrows plots for the period 2020 to 2022. You will define the start and end months for each season, loop through each season, import NOAA data for specific season and year, filter the data for specific months, of the current season, and then create the windrows plot for that season. Firstly, define the start and end years for the period. Then define the start and end months for each season. Then initialize an empty list to store windrows plots for each season. Then loop through the seasons. Finally, save the windrows plots for each season as PNG files. For example, this is rows plot for summer season. The windrows shows that the average wind speed during this season was 2.4 meters per second. Southwesterly wind was the most dominant. The strongest winds ranging from 6 to 8 meters per second primarily originated from the southwest. By following these examples, you will be able to create informative windrows plots for different time periods, gaining insights into prevailing wind directions and speeds, useful for various applications such as climate studies, urban planning, and renewable energy assessments.